Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and today we are dealing with geometry of 3D shapes, and let's get started. Problem 1. A closed cylindrical can has a radius of 4 centimeters and a height of 12 centimeters. A. Find its total surface area. So here we only use the formulas for a curved surface area of cylinder and for circle, but twice because we have top and bottom. So these are our formulas for surface area of cylinder curve and surface area of a circle. And in order to have area total, we have to add area of cylinder, so 2 pi times r times h plus 2 times area of circle, so 2 pi r squared. And now we have to substitute our values, so we have radius of 4 centimeters and a height of 12 centimeters, so 2 pi times r times 12 plus 2 times pi times 4 squared, and we have to calculate it. So our total area is 402 centimeters squared. And B, the company decides to increase the radius by 20% while keeping the height the same. By what percentage does the total surface increase? So firstly, let's calculate our new radius. So firstly, we have radius 4 centimeters, and now it increases by 20%, so we can multiply our former radius by just 0.2 and then add this value to our former radius, or we can simply multiply our 4 centimeters with 1.2, so it's like 120%, and this is 4.8 centimeters, so this is our new radius. And now we have to substitute this radius into this formula, so basically change 4 to 4.8, and then we will see our new total surface area. So our new value of the total surface area is 506, and we can leave some digits after point, so 676 centimeters squared. And now we have to calculate the percentage increase. So basically from our new value we have to subtract old value and divide it all by our old value and times 100%. And because in here we left our answer with 3 digits after dot, here we can also take value with 3 decimal places in order to make our percentage more exact, and the answer is 25.9999, so approximately 26.0%. Problem 2. A solid sphere has a volume of 900 cubic centimeters. A. Find the radius of the sphere correct to 2 decimal places. So firstly, let's recall our formula for the volume of a sphere. So this volume looks like this: 4/3 times pi times r to the power of 3. We know that our volume is 900, so we can substitute 900 in here. And now we can find r, so the radius, from the solver, or if you want you can simplify it However, it's not necessary. We have to only find the radius. And the radius is 5.99 centimeters. B. The sphere is melted down and reshaped into small cones of radius 1.5 centimeters and height 4 centimeters. How many cones can be made? So, firstly, we have to recall our formula for the volume of a cone. So, this is the formula, and now we have to substitute our values into this formula. So here we have 1 over 3 times pi times r, so 1.5 squared, and times 4, and we have to calculate it. So volume is 3 pi, and for now we can leave it like this because this is not our final answer, because we have to divide our former volume of 900 cubic centimeters, because this was the volume of a sphere, and then it was melted down, so the volume stays the same, and we have the volume of a cone, a small cone, so 3 pi, and we have to calculate how many cones can be made. So we simply divide 900 by 3 pi, and the answer is 95.5, so 95.5 cones. However, we cannot make a fractional cone, so we will make for sure 95 cones, because not 96, because we don't have enough this material to make 96. Problem 3. A cuboid has dimensions 6, 6, and 6 centimeters, a sphere inscribed inside it, touching all 6 faces. A. Find the radius of the sphere. So basically, as you can imagine, if we have a sphere inside a cuboid that has dimensions 6, 6, and 6, the radius is just half of it, so half of one dimension. So basically r is 6 divided by 2, so radius is 3 centimeters. B. Find the percentage of the cuboid's volume occupied by the sphere. So all we have to do is firstly find the cuboid's volume and then find the sphere's volume. So these are our volumes. The first one is the cuboid and the second one is spheres. And now we have to just divide our 36 pi by 216, because we calculate like the ratio of the sphere's volume to the cuboid's volume, because we want to know the percentage of the cuboid's volume occupied by the sphere, and times 100%, and we have to calculate it, and this is 52.4% to 3 significant figures. Problem 4. A right pyramid has a square base of side length 10 meters. The apex of the pyramid is directly above the center of the base, and its vertical height is 12 meters. A. Find the slant height of the pyramid. So the best thing that we can do in here is to draw our right pyramid to see how it looks like, and to basically see what we are looking for. So this is our drawing, and as our pyramid is a right pyramid, so it has square in the base, so this length is also 10 meters and this also, and we are looking for the slant height of the pyramid. So basically we are looking for this stance, let's say. So what we can do is to observe that we can make a triangle in here, and as our base is a square, so we can divide our base into 4 smaller squares, and we will have 4 squares with sides 5 meters. So here is also 5 meters, and we can use it to calculate our slant height from the Pythagorean theorem. So we have 5 squared plus 12 squared because we have in here our vertical height, and equals, let's denote it as L because it's slant height, so L squared. So 25 plus 144 equals L squared. So L equals square root of 169, and this is just 13. And of course, meters. B. Calculate the angle between one triangular face and the base. So we have 4 triangular faces, and we know the slant height of each one because these triangles are the same. So this is our triangular face. So we have to calculate basically this angle between one triangular face and the base. So we can redraw this triangle, this smaller triangle, because we are calculating this angle, so this angle is inside this triangle. So this is our triangle. Here we have alpha. Here, of course, we have right angle, so 90 degrees. Here we have 5 meters. Here we have 13 meters, and here we have 12 meters. And in order to calculate this alpha angle, we can use both sine rule or this short formulas SOH, CAH, and TOA. So we can, for example, use the sine rule. So we are looking for this angle. So we take this side. So 12 over sinus alpha equals, and something that we have, so 13 over sinus 90 degrees. So 13 over sinus 90 degrees. So our angle is 67.4 degrees, and you can also try to solve it with one of these formulas or with every formula, because we have every side. We have opposite, we have hypotenuse, and we have adjacent. So we can use, for example, sine. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you can try it by yourself and check whether the answer is the same, because it has to be the same. And point C, find the total surface area of the pyramid. So basically we have to add the surface area of our 4 triangular faces and area base. And here we had point B, so now point C. So surface area is our base, so 10 times 10 because it's square base, plus 4 times, and the formula for a triangle, so 1 over 2 times A, so 10, and times H, so 13, and we have to calculate it. And this is 360 meters squared. Problem 5. A sphere of radius 5 centimeters is placed inside a right circular cylinder of radius 6 centimeters and height 15 centimeters. The remaining empty space is filled with liquid. A. Find the volume of liquid. So as you probably know, we have to subtract the volume of sphere from the volume of circular cylinder. So let's firstly rewrite the volumes for these both figures. So these are our formulas. The first one is for the volume of the cylinder, and the second one is for the volume of a sphere. So now we can substitute our values. So pi times radius 6 centimeters, so 6 squared, and times height, so 15. And here we have 4/3 times pi and times r, so 5 to the power of 3, and we can calculate it. And these are our answers, and I left it intentionally with pi because that's not our final answer. So our final answer can be left without this pi. However, here this is more exact value. So now we have to just subtract from 540 pi 500/3 pi, and this is our answer, 1172.86 cubic centimeters. B. If the liquid costs $0.05 per cubic centimeter, calculate the total cost of filling the empty space. So we can do it in any way you want. I think that the easiest one is to make proportions. So we have cost of 5 cents per cubic centimeter, and we have 1172.86 cubic centimeters. So our cost is unknown, and our and here we rewrite our value. And now we have to multiply this with this and then divide by this. And of course our cubic centimeters cancel out, and our answer is $58.64. Problem 6. A hemisphere of radius r is placed on top of a right circular cylinder of radius r and height 2r. A. Show that the total volume of the solid is 8/3 times pi times r to the power of 3. So as you probably know, we have to just add these volumes and then just prove that the volume of this whole solid is 8/3 times pi times r to the power of 3. So firstly, let's write down the volumes for the circular cylinder in the hemisphere. However, we don't have the volume formula for the volume of hemisphere in our booklet. However, we remember that hemisphere is just half of the sphere, so we have to take the volume for the sphere and multiply it with 1/2, or just divide this formula by 2. So these are our formulas, and let's substitute values that we have. So, or letters, because we actually have letters in here. So a hemisphere of radius r. So here we write 1/2 and in bracket 4/3 times pi times radius r. So we leave r, of course, to the power of 3. And in a cylinder we have radius r and height 2r. So pi times r squared times 2r. So now in order to have the total volume of the solid, we have to add these values. So these are our values. So here we have 2 times pi times r to the power of 3 plus 4 over 6 times pi times r to the power of 3. So this is 2 over 3. So 2 plus 2 over 3 is basically 8 over 3 times pi and times r to the power of 3, and this is our volume that we had to show. B. A company wants to design such solids so that their surface area does not exceed 500 cubic centimeters. Find the maximum possible radius r, correct to 2 decimal places. So firstly, we have to know which surface areas we are adding. We have hemisphere and we have circular cylinder. So of course we have to add surface area of hemisphere, curved area of our cylinder, and also we have to add bottom circle because it's our basically bottom. So we have to include these 3 surface areas. So let's firstly write down their formulas. So these are our formulas, and of course in a hemisphere we take half of surface area of the sphere because we don't have this formula in our booklet. And now next step is just to add these values to each other. So firstly we can simplify this firstly. So 2 pi r squared. So we have 2 pi r squared plus surface area of a circle, so pi r squared plus 2 pi r, and we remember that height was 2r in cylinder, and we have to simplify it, of course. 2 times pi times r squared plus pi times r squared plus 4 times pi times r squared. So we have 7 times pi times r squared, and we know that the surface area does not exceed 500 cubic centimeters, and we have to find the maximum possible radius r. So we can write that 7 times pi times r squared equals 500. We know that it has to be smaller or equal to 500, but we can solve it like this in our solver. So our radius is 4.77 centimeters, so this is the maximum possible radius. And of course we could also write that 7 pi times r squared is equal or less to 500, and then divide both sides by 7 pi, so r squared is equal or less to 500 over 7 pi, and then take the square root of both sides, so something like this. And now we are sure that our radius is equal or less to 4.77 centimeters. But if we have something like this, we can simply type it into our GDC into solver and quickly have the results. And that was the last problem from this topic, geometry of 3D shapes. And if you found this video helpful and useful, you can share this video to your friends, leave thumbs up, subscribe to this channel, and in case of any questions, You can write them down in the comments down below or via my mail that is as always in the description of the video. Bye!